Alright, in this video I'm going to do an example of solving nonlinear systems by graphing, and really just to go over some quick notes and ideas. Basically you graph both equations and then you look for points of intersection, and there's really three cases that can occur. Case 1 is you graph both functions, and when they cross each other they hit twice, so you have two solutions. You can also have a situation where you graph both functions and they hit once, where you have one solution. And then you can also have it where you graph both equations and they don't hit and you have no solutions. So really the idea, once again, is that your solutions are going to occur at points of intersection. Now, with the example that I have here, we have y equals x squared minus 2x minus 1, and we have y equals negative 2x minus 1. The first equation here is a quadratic equation because it's being squared, so this is going to end up looking like a parabola. And then the second equation here is of the form y equals mx plus b, so it's actually going to look linear and act more like a straight line. So I'm first going to graph this quadratic, and remember, to find the vertex of a standard form quadratic, to find the vertex we need to take the opposite of b, which is 2, and then put that over 2a. Well, right now my a is 1, so it's going to be over 2. So the x coordinate of the vertex is just 1. And then to find the y coordinate of the vertex, I have to plug 1 back into the equation and solve for the y. Well, if I plug 1 back in, I'm going to get 1 squared minus 2 times 1 minus 1. Well, 1 squared is really just 1. Negative 2 times 1 is negative 2, and then minus 1. Well, that's going to end up coming out as negative 2. So my vertex is at 1, negative 2. And then if you notice, my a is 1, and if I put that over 1, whenever I go over 1, I go up 1, over 1, up 1. So my quadratic equation, its graph looks something similar to this. And then now I just want to graph this y equals negative 2x minus 1. Well, negative 1 tells me where the intercept is, so the intercept in this case, y-intercept is going to be at this point. And then negative 2 slope, I put that over 1, and it tells me when I go over 1, I'm really going down 2. And when I go over 1 the opposite direction, I'm really going up 2. So in this case, the graph cuts through, hits that point, and misses the other points. So as I can see, I look for the point of intersection. Where do the two graphs intersect? And it looks like it intersects at this point here, which is the point 0, negative 1. And that will end up being the solution for this system of nonlinear equations.